Hello, mathematicians, puzzlers, and other curious people. I've got some new programs to try out here. One that you've seen before, GeoGebra, and one that's new to me called StreamYard. I'm trying that to see if I can do a few different things with this. So please bear with me if there are more glitches than usual. I'm trying to make everything work. And I'm going to use GeoGebra as part of this streaming feed to hopefully, if it all goes well, build a common fractal. So here we start with a blank, sort of plain non-gridded surface with an X and Y axis. I'm not going to actually use the axes for very much here, but I'm going to set up a single point. Actually, first I need to set up a number, and I'm going to use this for something later on. Don't worry about it, but it's somewhere in this menu where I can just create a slider, a number. They've changed the name of it a couple of times. Let's see. I don't see it. Where is it? Well, this would happen when I'm like, okay, here we go, slider. That'll do. Okay, so I'm going to have this slider go from 0 to 10 in increments of 0.1. And that's going to just sit quietly for a minute. It's going to just give us a random, or not a random number, but a number that will slide around. Now what I'm going to do with that is plot a point at 0A, where you'll notice A is the number from that slider. So that goes right on there. Now the cool thing about it is when I have that number change, that point automatically moves. Now, I want this to be decreasing instead of increasing. So let's see. Where is that? Not in that menu. Sometimes you have to try a couple things. Okay, animation, whoops. Okay. Okay, so it's bouncing back and forth. Now, come on. I've done this before. Ah, wait, I just saw it and then it disappeared. Why does that happen? Okay, no problem. Instead of oscillating, I'm going to set it to decreasing. So now it's going to look like that, always. And that point is always going to slide down the axis. Okay, now I don't actually need to see this. And I don't actually need to see the axes for what I'm going to do next. Now I'm going to start by putting a circle around that point. Now the next thing I'm going to do is come out and put a few more circles around that circle to build a few things out. Yes, there was more than one way to do this part. And using those points that are constructed, I'm building a triangle. Okay, so now I don't need those circles for anything else, so I'm going to go back through and hide them. And I don't think I'll need points C and E again, the vertices I might. And I don't actually need my original point anymore. Now again, what's important about this is, interesting. That's not quite the behavior I had in mind. Okay. That's not what I had in mind for that point to be stuck, so I'm going to try something different. And this is a process that often happens in math, trying different things. Let's see. What I really want is a circle. There you go. So I want a circle using point A as the center, and then as its radius, I don't know, let's try 2 units. Okay, now let's see if that worked. Why is that not recalculating? Okay, there we go. That's better. Sometimes you have to give it a moment. Okay, so now let's try this again. So I'm going to drop a point onto the circle, and I'm going to check and make sure Yeah, okay, now the circle is sliding down, the points going along with it. Fabulous. That's more like what I had in mind. So now I'm going to repeat what I had done before. I'm using that to kind of mark off distances around the circle. Basically what I'm doing here is I'm coming up with the points needed for a perfect hexagon or a perfect equilateral triangle, and then I'm only using half of them, so it's the equilateral triangle that I get. Okay, now let's go back and hide all those circles again. Okay, and we can hide point A. And now if I run that, well, I've got a falling triangle. Okay. Okay, so for real this time, I think I'm done with the axes. So now what am I going to do with this falling triangle? Well, what I want to do is build some more little triangles coming off of the sides in a particular pattern called the Koch Snowflake. That's a particularly well-known fractal, and it's one that mathematicians find very interesting because it's pretty easy to draw, at least to draw a certain amount of iterations of, but it's still got a lot of interesting properties to it. Okay, so what I'm going to do here is I'm going to sort of come off of these sides and draw out a triangle that'll basically have points roughly there, there, and there. But the problem with just drawing that on is those, except for the one that happened to get on there, are not determined by the animation like they're supposed to be. So those 3 points aren't actually the ones I need. They're just rough estimates. I want to be exact. So the way I'm going to do that is a little bit sneaky. So what I'm going to do is draw a line coming off of that corner. Now the next thing I'm going to do is, whoops, other way around, draw circles coming off of that. Now what you'll notice is that the distance between points B and J is the same as the distance between points K and J, because those are each a radius of the same circle. Likewise, the distance between K and J and L and K. Well, that means we've got 3 equal line segments here. Now this next thing is a little bit clever. What I'm going to do is drop a line to there and then go parallel to it through the other points. And what that does is trisects the segment from point B to point D. So we've got 3 equal pieces there. So then all I have to do is drop those 2 points, and then I can put on a circle off of each, and you'll notice that the other end of that circle, or kind of the opposite side of that circle, goes out to the corners. Not a coincidence. Again, it's because we trisected, so each of these segments, DM, MN, and NB, are equal. And there I have a point I need to make another triangle. So I know this kind of seems like a lot. I'm going to go through and hide the things we didn't actually need. So let's see. The circles. That I used. Those lines can go. Those circles can go. And that point can go. Okay, so it seems like we did a lot for just a little in a way, but we can get a little more use out of that, because watch this. Then the next thing we can do is do a little reflecting. Well, what are we going to reflect across? Well, we need something to reflect across. That's true. So I'm going to take a perpendicular bisector of this. You'll notice that it's a line of symmetry for the triangle. And then I'm going to come down to construction tools and reflect these 3 points across that line. From there, it's very easy to sketch in that segment, like so. And I'm going to do the same thing again with, let's see, what I really need is, okay, I'll bisect the corner from B to F, or the edge from B to F, and then I'll come across from there. So let's see, constructions, perpendicular bisector, and it goes right on. So that'll reflect my originals M, N, and O onto the third side. Let's see, transform, reflection about a line. And again, there's more than one way to do this also. So if something else is popping into your head as a method for trying this out, well, fire up GeoGebra. It's free for everybody, and try it out and see if it works. Okay, so now for a moment, I'm going to hide those two lines that I made. The perpendicular bisectors. I'll bring them back in a while, but I want to show you what this is actually doing. So remember we were animating? So we've got something that's starting to look a little more like a snowflake that's falling through the air. Now we can make it look even more like a snowflake by taking some more labels off. We'll do that afterward, but we're getting to it. Okay, I might need those perpendicular bisectors again, so I'm going to go ahead and re-show them. And now I'm basically going to repeat this process. Let's see. So I need to pick a point to kind of come off of. I'm going to use point D this time. And again, I'm going to come off of that point with a couple of circles, using the circles to measure off 3 equal portions of this line, and then using a parallel line that didn't work. Oh, I know. I need to give myself a reference before trying to use a parallel line. I skipped a step. That's a thing that happens in math. People will try to skip a step, and if they're paying attention, they'll notice that it didn't work. It happens. Okay, so now we've got our reference line and our 2 parallels that came off it, and we clearly notice that we've got those 2 points there. I'm going to zoom in to make it easier to see what we're doing here. So once again, we're going to use a circle to construct that smaller triangle, and this is really a proper mess. So I'm going to come back here and let's see. I'm going to hide those parallels. That line there, it's hard to see at this angle what that is. Let's see, that one. I might use that one. Well, wait, let me see if that's the right one. Okay, no, that one's not what I need after all. So I'll hide that one. And those circles. This line, that was just for a reference. Okay, so now that's a little easier to see what I'm doing in here. So now again, I'm sketching that on. That was a lot, right? Well, fortunately, now that we've got one triangle of that size on here, we can kind of work our way around and make it a little easier on ourselves. So I see that we certainly need to reflect that little triangle across this line. So I'm going to come to my reflection tool and say, okay, let's reflect you, you, and you across that. Well, I'm also going to need to reflect across this. Where'd that go? Yeah, see, that ends up over here. Okay, well, now I notice that I could reflect these across this. Let's see, did that end up at the same place as something? Oh, no, that ended up back where it started. Let's see, oh, other one, right. Whoops. Okay, and that's got a lot of it, but not all of it yet. So let's see. We've pretty much exhausted, well, no, not quite. I can get this region over here covered. Let's back off a minute and see what that really gives us. Oh, whoops, I missed one. Let's see, reflecting, across the line. Let's see, we got T, we need S. There it is. I'm just going through and clicking the pairs of vertices that are going to correspond to each segment that I'm making, 2 segments per triangle. And then let's hide those circles. Which ones are those? Here we are. Yes, those circles there. Okay, now what I'm seeing is what we're missing is the stuff that would be through here. So like here and here, here and here, here and here. And if we can get it to one of those places, we can use the reflections to get it to the rest. The trick will be getting it to them in the first place. So we need another bisector to get things into the right place. So I'm going to construct another perpendicular bisector, and I'm going to use this angle here, O, not a perpendicular bisector for a line, I need an angle bisector. Whoops, there we go. ONB. Okay, see how that kind of makes something that'll mirror image this stuff through here to over there, and from there we can just run with it. So now let's do that. Let's get those transformations. Let's see, reflect about a line. That point, that point, that point. Let's see. Now let's reflect those to there. This is so fun. We can reflect these across this one to here. Let's see. What have we not got to yet? Oh, okay. This same line, let us reflect that. Whoops. That across to there, that to there, and that to there. And then from this, we can get that, that. Oops. I keep misclicking. Why does it do this? And that. Okay, let's see. Over here is still missing, but that's this across there. Okay, and I believe that's everything for this iteration. So I'm going to go around and put on the segments again just to check. So our first iteration was the big triangle in the middle. Our second iteration was the 3 little triangles that came off its sides. The third iteration is the figure we have with the, let's see, 2, 4, 6, 12 littler triangles. that came off all those locations. I'm just going to do one more. And again, it's going to be a very familiar process at this point. So we will draw a line off of a convenient point. And I'm going to zoom in to make this easier. Having drawn that line, I will use a couple of circles to measure off some equal distances. Now what I'm trying to trisect, cut into 3 equal pieces, is this segment right here. So I'm going to drop a line from my furthest out of the 3 things up to there. I can even move this over a little bit to make it easier to see, make that a little bit of a less steep angle. And then I need some parallels. So parallel to this line through this point and this point lets me see where those trisection points are. And now I'm going to go ahead and hide that trisection gadget with the extra line and the stuff from the circles, the parallels, let's see, and that there. So now once again, I'm going to use a circle off of those 2 points to find the point out there that will give me a perfect tiny triangle. I'm going to hide those circles because I don't need them for anything else. Now I'm going to step back out. I'm going to say, okay, time for a lot of reflecting. Let's see where this will go. So just like I needed another reflection line for the previous iteration, I'm expecting to need an additional reflection line for this one. I'll get there when I get there. So let's take a look. So we're coming down to the transformation tools using Reflect About Line again. I don't see where these are ending up because it's off the screen. I'll check on that in a moment. Ah, yes, they ended up over here. From there, I can do these. Let's see. I can also do those. Let's see what else I can do. Let's see. I can get that. I'll just go ahead and do that whole peak from here. Okay, let's see, what else? What am I missing? I went back to the same space. Okay. Let's see, what do I still need here? Whoops. Oh, I see that there's some stuff up here that hasn't been done, so I'll go ahead and pop up. Now this is where it gets tricky because it's hard to zoom in close enough that you can see what you're doing, but still get all the way across. So you have to kind of go back and forth a bit. So sometimes people want to know, how long can you keep doing this? Well, there's not a rule. You can keep doing this as long as you have the patience for it. Now, in practice, most people don't have the patience for more than 3 or 4 iterations, maybe 5, but you can always come back to it and do some more later, as long as you have a way to keep track of where you left off. Let's see, that can go across there. Whoops. Okay, where did that go? Huh, weird. A lot of stuff just disappeared. I'm not sure why. GeoGebra must be having a little bit of an issue for some reason. But that's okay. We'll just keep going. Let's see. Okay, so this needs done. Let's see. Something's missing over here. It's the further out of those. Okay, so this right here reflecting across that. And then reflecting across that gives us that. Okay. Let's see. I see that this side of that peak hasn't been done. So we can get that. Whoops, not from that one. That's the inner one. What in the... It's weird. Every time I go to undo something, it's like it undoes too much. That's definitely an unexpected behavior. I don't usually have that problem with GeoGebra. I suppose it's playing up because I'm live. It doesn't make sense, but in a way it does, so we'll go with it. I'll just have to try to remember to use the undo button or delete what I had just accidentally done instead of using Control-Z. That's going to be tricky because Control-Z is so useful usually, but if it's going to be a problem, I'll just try to not do it. So that's making this iteration take a little longer than it would, but the 4th iteration would take a while anyway, because there are so many tiny triangles. Okay. Let's see. Does that go? Yes, over there. I'm sure there was a way I could have seen ahead about that, but sometimes a really great mathematical process, or sometimes one really great mathematical problem-solving tool can be push buttons and see what happens. Okay, let's see. So we're reflecting points across a line to make more points. Let's see. Okay, so it looks like we've got the outer bit of all that, like the very outermost bit. So now here's the tricky part. What we need to do now is get basically every other kind of thing. So we need to do a little more reflecting. So we've got lots of different lines going, lots of different directions. I notice that we're going to need to get stuff into this space here. So I'm using that new reflecting line that I just made to try to do that. So that'll go over to there. And while I'm at it, I may as well do that directly. Now that I've done those, I can reflect them across this reflector line that I already had and start working my way around. Oh no! It went too far. Oh, arg. This is frustrating. Apparently the undo button doesn't work any better than Control Z. Okay, so I'm going to be at this a little longer, I guess. That reflects across there. I really wish I hadn't pushed that button. But oh well. I can't unpush it, unfortunately. Let's see. My eyes are starting to cross from doing this too long. Let's see. That stuff up there needs done. So that, that, that one, C2 and B2 and A2. Let's make sure that worked. Okay, looks pretty good. I can reflect those, I think it's the inner ones, yeah, the inner ones across to there. Then I can reflect across this line with these all. And put those points that are needed around that outer peak. Let's see what still needs done. Okay, so I've got all my outer peaks again. I'm going to save because I'm tired of going back that far. Okay, so once again, I'm going to see what I can do with one more reflector. So first I'm going to make that reflector line. It's an angle bisector. I'm going to use this one, this one again. It seemed to work before. And then I'm going to just start reflecting things across it. So as you can see, that kind of spreads out, and then I can kind of back reflect them onto the other side. And I know this seems like a bit of work, but it's sure a lot easier per point than trying to use that trisector tool to construct them individually would be. Okay, now what if I reflect all that across this? Well, then it ends up there. Q, P, R. I need to remember that that's where I left off, but I need to move this up a bit so I can see what I'm doing. Okay. QPR is what I did, so I'm going to start again with T, S, and U, and I'm basically just rotating around this. Whoops. Don't undo. Delete. If I can just remember to, when I misclick, delete instead of undo, then that should be fine. Okay, see how all those points showed up? It seems like a bit of a miracle, but all we did is go around. Okay, so I see that the equivalents of those points across there are not already in place. Now I see that through here I may have doubled some points, so I'll just go in and delete the extras. Oops. Can I undo without it going too far? I cannot. Okay. Can I revert to what I had just saved? I can. I wish I had saved more recently. Well, we will save more often because it's what we can do. Okay. So let's see, I had used an angle bisector right here. We are definitely getting plenty of practice at finding these tools in the GeoGebra menu. That's a fact. We're reflecting, and then we're back reflecting. I suppose I should have saved a copy before I deleted anything. There's probably something deeply meaningful about data security in that. And if I can just remember that, I think that's a good rule to follow. Let's see that. And that's the same as that one, but this one isn't already there. Yeah. Okay. So I think this is going to be the last iteration because we're, well, running up against that level of patience barrier. But that doesn't mean we're going to stop before it's done. Okay. I wonder if I can, well, I'm going to save this first. I wonder if I can get away with reflecting more than one point at a time. So let's see, sometimes Shift allows for selecting more than one thing at once. Nope, Shift isn't, maybe Control. Okay, what just happened? Okay, apparently it's strictly one thing being reflected. Or if there's a way to do more than one, I haven't found it yet. Okay, that mid-peak is already there, so I'm just going to come around to the third sort of sub-peak. Okay. That's pretty good. I'm going to work across from this now. Oops. Okay, I see I put 2 in the same place by mistake. I'm going to save first, and then I'm going to go in and delete the extra one. Okay. There, save before you delete. That's a good rule. Something's missing here. Let's see. Should be, corresponds to not that one, but this one right here. Why is that not letting me click it? Okay, there we go. Okay, now that's not missing anymore, and I can reflect it where it needs to go from this. So let's see. That goes across there, and that goes there, and that goes there. And then from there I can say, okay, that and that and that should go there. That. Don't undo. Just delete the unwanted point. Okay. Okay. It's so hard to not undo. I've been doing that. I've been hitting Control Z when something goes wrong for so long. It's hard to unlearn a thing. Okay. Just because it's hard doesn't mean we can't do it. It just means it might take more tries to get it right. Okay. Where are we now? I see that these points still haven't been done. Let's see, those, let's see, I mean these ones over here and here. Well, those are across this line from those other points, so I can use that. So let's see, let's take U and reflect. U, reflect. Reflect that also. And this, and that, and the other. Also around this. And P, R, and Q here. Okay. And now I see that that some points across from that need to be reflected on. So, okay, that'll work for that. And then that can go across that line. Don't undo. Delete the extra point. And I've had to stop and remind myself not to do that a couple of times. So that tells me it's a good time to save just in case. Would not want to press my luck. Now people say that there's no such thing as luck, but there is the comparison between what you wanted to have happen and what actually does happen, and luck is as good a name as any for that. So if what you wanted to have happen is just about what happens, or if what happens is even better than what you thought of, well, then that could be what we call good luck. If it's the other way around, that could be something we could call bad luck. Okay. So I think now I've got everything except all the way around these little inner bits here. And what I'm not immediately seeing is a good, clear way to get to that, except maybe over here. So what I can use is an angle bisector right here. And now I'll have a line that reflects across that, or a line so that, for example, this point reflects to there, and this to there, and this to there. Now I can use this reflector line I already have to get that and that and that. Let's see. Now I can use this reflector line that I already have to get that and that and that. Okay. What do I already have? let's see. Well, I can definitely take what I've done so far and reflect it all the way across. Those and these. Okay. Now I can use this line with these points. I think we're in the home stretch of this iteration, but now that I've said that, I'd better save just in case. It might be silly, but it's doing something good for a silly reason, so we go with it. That's not quite right. What did I misclick? I don't need a point out there for anything. Okay, let's see. This across that. There, that's better. And that. And that. And there. There. And there. Okay. Over here is still missing, but that's across from these. If I use this line, so that, and that, and I want to say last. I'm not going to quite say it, but nearly last but not least. Maybe last. I don't see any major gaps. Okay, so now what I need to do is go around with the segments. Actually, I'm going to save again just in case. And we're working our way around, drawing on the tiny little triangles. Teeny tiny triangles. Let's see, up here hasn't been drawn on yet. Oh, and there's one right there. Working our way around. Now you can see where we could do another iteration. I'm not going to right now, like I said, because the level of patience is running down a little bit, and I'm just about ready to take a break from staring at teeny tiny points. Both math and creativity have staring at the same thing for quite a while as things that happen, and that's fine. But detail work is the kind of thing that's best done in small bursts, or you start making mistakes you didn't have to make. So it's really good now and then when you're doing detail work to step away from it, and it's really important to know when you could use some time stepping away from that detail work. That doesn't mean you don't come back and finish, and if you're close to a good stopping point when you're getting ready for a break, it's okay to try to press on to get to the better stopping point. That's what I'm doing right now. I'm making a point of getting through this last iteration so that I can see how this is going to turn out, because I really want to see how this turns out. Almost there. We're coming around the bend. Let's see. I noticed that we're using the same letters 6, 7 times. Well, if we've been through the alphabet that many times, that means, let's see, for convenience, let's round the alphabet to 25 letters. That might be a little high estimate because it looks like we skipped X and Y, but whatever, 25 is close enough. So if we have 6 times 25, that'd be 150 little points. Plus we had to do several of them more than once because of the thing resetting, so no wonder my eyes have about had enough. But we're not quite done yet. Now the next thing I'm going to do is come down to this polygon tool, and I'm going to start at one point, and I'm going to play connect the dots all the way around. And yes, I do mean all the way around. Every single point that we made on here is going to be part of this polygon that we're making. All the way around, because if we skip any, it won't quite look right. And as we go around, you can see how it's marking the perimeter in dark blue and the area in light blue based on just its best guess, based on the points we've marked so far. Now, it doesn't try to guess which other points we're going to mark. So it just says, okay, well, whatever last one you marked, we think maybe you're going to come back to the beginning from there. Let's see, we're almost halfway around. Just a little bit further and then we'll be halfway. Okay, that's halfway. So you can see sort of a half snowflake here. I'm gonna zoom out and back in to get a few more. And a little further. In and out, in and in, back out. Now as we're zooming out, GeoGebra takes a moment where the polygon that it's sketched on is holding still, even though the rest of the figure that it's generated from is moving, and you can kind of see at that time really the outline of what we're making. I can't see enough to be sure, but I think we're about 3/4 of the way around now. It gets tricky trying to remember where you started. Oh, I see that out here. It looks like I left off some segments, but it's not going to matter because I can still see what needs to be connected up as part of the polygon. So we can handle this. That part's okay. Oh, almost done. See how almost the whole area is filled in? And then back to that last point. Okay. So now I'm going to go through and hide practically everything, even those corners. I notice we've got a lot of points that are marked with a prime also, so 150 might be a low-end estimate of how many vertices this polygon, that's the third iteration of the Koch snowflake, has. We've got some double primes and triple primes. So really, that's about another 3 trips through the alphabet. It's really probably more like 300 than 150. That was quite a low estimate then. Well, that sometimes happens when you miss something. It's okay. We found it. So we've got a more accurate estimate now. And we're hiding points. And as you can see, the more points we hide, even though the snowflake is still defined by those points, so it's still got them in the shape, the easier it is to really see the points of the corners. Wow, we've got a lot more, but that's okay. We'll get through it. It's just clicking. It's not that hard. Ooh. Almost there. Almost. Just a few more. Okay, I'm going to leave those on. Those are the outlining ones for the polygon. And I'm going to do something with that point B. If it'll let me. And it will. So now that we've built this snowflake, we can zoom out and watch it fall to the ground. Oh, stop spinning. There we go. So remember, point B was on the circle. And what that point does is it determines one of the corners of the triangle that we started with. And as that point moves around on the circle, the whole rest of the triangle that's a perfect equilateral triangle that's the base of that spins with it. And in so doing, the whole rest of the triangle comes along. So that's what I had for you today. I am definitely going to save this. I'm going to jot on that, save forever, because that took what felt like forever to make. So I sure had fun in this. I hope you all had fun. I hope you saw some things you want to try. So I'm just going to say for now, calc you later.